Imagine a world without ice at the North Pole. No more vast, white expanse stretching across the top of our planet. Instead, picture open ocean where polar bears once roamed. This isn't science fiction. It's the future we face if we don't act now. The North Pole, once a symbol of icy permanence, is melting at an alarming rate. The Arctic is warming faster than any other region on Earth. This warming trend is directly linked to human activities, primarily the burning of fossil fuels. Greenhouse gases released by our cars, factories, and power plants are trapping heat in the atmosphere, causing our planet to warm. And the Arctic, with its delicate balance of ice and snow, is feeling the heat most acutely. The consequences of a melting North Pole are profound and far-reaching, impacting not just the Arctic region but the entire planet. Sea levels will rise, threatening coastal communities around the world. Weather patterns will shift, leading to more extreme weather events like hurricanes, droughts, and floods. And wildlife, like the iconic polar bear, will face an unprecedented struggle for survival. The time to act is now. We must reduce our reliance on fossil fuels and transition to cleaner, more sustainable sources of energy. The future of the Arctic, and indeed the future of our planet, depends on it. The primary culprit behind the melting North Pole is climate change, driven by the increasing concentration of greenhouse gases in the Earth's atmosphere. These gases act like a blanket, trapping heat and causing the planet to warm up. This warming is not just a future problem, it's happening right now, and the effects are most visible in the Arctic region. These gases, primarily carbon dioxide released from burning fossil fuels, trap heat from the sun, leading to a gradual warming of the planet. Fossil fuels like coal, oil, and natural gas are burned for energy, releasing large amounts of carbon dioxide into the atmosphere. This process has been accelerating since the Industrial Revolution, and the impact is now undeniable. This phenomenon, known as the greenhouse effect, is essential for life on Earth, but the enhanced greenhouse effect, caused by human activities, is pushing temperatures beyond natural limits. The natural greenhouse effect keeps our planet warm enough to support life, but human activities have intensified this effect, leading to global warming and climate change. The Arctic region is particularly vulnerable to this warming trend due to a phenomenon known as Arctic amplification. This means that the Arctic is warming at a much faster rate than the rest of the world. The loss of sea ice and snow cover, which reflect sunlight, exacerbates this warming. The loss of ice and snow, which reflect sunlight back into space, exposes darker surfaces like ocean water, which absorb more heat. This creates a feedback loop where warming leads to more ice melt, which in turn leads to more warming. This feedback loop is a significant driver of the rapid changes we are seeing in the Arctic. This creates a feedback loop, accelerating warming in the Arctic at a rate 2 to 3 times faster than the global average. The consequences of this rapid warming are profound, affecting not just the Arctic ecosystem, but also global weather patterns and sea levels. The burning of fossil fuels, coal, oil, and natural gas for energy is the largest contributor to greenhouse gas emissions. These activities release vast amounts of carbon dioxide and other greenhouse gases, which are the primary drivers of climate change. Deforestation, industrial processes, and agriculture also play a significant role. When forests are cleared, the carbon stored in trees is released into the atmosphere, adding to the greenhouse effect. Industrial processes and agricultural practices also contribute significantly to greenhouse gas emissions. These activities release billions of tons of carbon dioxide and other greenhouse gases into the atmosphere every year, trapping more heat and exacerbating the warming trend. The cumulative effect of these emissions is a planet that is warming at an unprecedented rate, with the Arctic serving as a stark indicator of these changes. Understanding the causes of Arctic warming is crucial for addressing this urgent issue. Scientists are working tirelessly to study the changes in the Arctic, using advanced technology and satellite imagery to monitor ice loss and temperature changes. We must transition away from fossil fuels and embrace renewable energy sources like solar, wind, and hydropower. These renewable energy sources produce little to no greenhouse gases, making them a key part of the solution to climate change. Reducing deforestation and promoting sustainable land management practices are also essential. Reforestation efforts can help absorb carbon dioxide from the atmosphere, while sustainable agriculture can reduce emissions from farming practices. The fate of the North Pole, and indeed the planet, hinges on our collective action to mitigate climate change. Governments, businesses, and individuals all have a role to play in reducing emissions and protecting our environment. The time to act is now, before the changes become irreversible. One of the most immediate and dramatic consequences of a melting North Pole is the rise in global sea levels. This phenomenon is not just a distant concern for future generations. It is happening right now and affecting millions of people around the world. The melting ice contributes to the volume of water in our oceans, causing sea levels to rise incrementally but steadily. The Arctic ice cap, a massive expanse of ice covering much of the Arctic Ocean, acts as a giant mirror, reflecting sunlight back into space and helping to regulate Earth's temperature. This reflective quality, known as albedo, is crucial for maintaining the planet's climate balance. When the ice melts, darker ocean water is exposed, absorbing more heat and accelerating the warming process. As this ice melts, the volume of water in the ocean increases, leading to rising sea levels. This is not just a simple rise in water. It has complex and far-reaching effects on marine ecosystems, weather patterns, and human settlements. The additional water can lead to more frequent and severe coastal flooding, affecting both natural habitats and human infrastructure. The Greenland ice sheet, another significant ice mass in the Arctic region, is also melting at an alarming rate. This ice sheet is one of the largest in the world, and its melting contributes significantly to global sea level rise. Scientists have observed that the rate of melting has accelerated in recent years, raising concerns about the long-term impacts on global sea levels. This massive ice sheet contains enough water to raise global sea levels by over 20 feet if it were to melt entirely. While this scenario might seem extreme, even a partial melting of the Greenland ice sheet can have devastating effects. The water released from this ice sheet can disrupt ocean currents, which play a crucial role in regulating the Earth's climate. While a complete meltdown is unlikely in the near future, even a partial melting will have significant consequences for coastal communities worldwide. These communities are already experiencing the effects of rising sea levels, such as increased flooding, erosion, and saltwater intrusion into freshwater supplies. The impact on agriculture, drinking water, and overall quality of life can be severe. Rising sea levels pose a direct threat to millions of people living in low-lying coastal areas. These areas are particularly vulnerable to storm surges and high tides, which can lead to devastating floods. The displacement of populations due to rising sea levels is becoming a growing concern, as more and more people are forced to leave their homes and relocate to safer areas. Cities like Miami, New York, Shanghai, and Mumbai are all vulnerable to even modest increases in sea level. These major urban centers are home to millions of people and are economic hubs that drive global commerce. The impact of rising sea levels on these cities can lead to significant economic disruptions, affecting not just the local population, but the global economy as well. Coastal erosion, flooding, and saltwater intrusion into freshwater sources are just some of the challenges facing these communities. The loss of land due to erosion can lead to the destruction of homes, businesses, and critical infrastructure. Saltwater intrusion can contaminate freshwater supplies, making it difficult for communities to access clean drinking water. The economic costs of rising sea levels are also staggering. The damage to infrastructure, loss of property, and the need for disaster relief can strain local and national economies. Insurance companies are also feeling the impact, as the frequency and severity of claims related to flooding and other climate-related events continue to rise. Protecting coastal infrastructure, relocating populations, and dealing with the aftermath of extreme weather events will require significant financial resources. Governments and communities will need to invest in building seawalls, improving drainage systems, and developing early warning systems to mitigate the impact of rising sea levels. The longer we wait to address climate change, the more severe and costly these consequences will become. Immediate action is needed to reduce greenhouse gas emissions, transition to renewable energy sources, and implement policies that promote sustainability. The future of our planet depends on the actions we take today to combat climate change and protect our environment for future generations. The melting North Pole is not just about rising sea levels, it's also a catalyst for profound and unpredictable changes in global weather patterns. The ice caps, which have existed for millennia, are now shrinking at an alarming rate, and this has far-reaching consequences for our planet. The loss of ice not only contributes to higher sea levels, but also affects the global climate in ways we are only beginning to understand. The Arctic, with its icy expanse and unique atmospheric conditions, plays a critical role in regulating Earth's climate system. This region acts as a global thermostat, reflecting sunlight and keeping the planet cool. The ice and snow cover in the Arctic have a high albedo effect, meaning they reflect a significant portion of the sun's rays back into space. This helps to maintain the Earth's energy balance and keeps temperatures stable. As the Arctic warms and ice melts, it disrupts these delicate balances, leading to a cascade of effects on weather patterns worldwide. The loss of ice reduces the albedo effect, causing more solar energy to be absorbed by the Earth's surface, which in turn accelerates warming. This warming is not confined to the Arctic. It has a ripple effect that influences weather systems across the globe. One of the most significant impacts is the disruption of the jet stream. The jet stream is a fast-flowing ribbon of air that circles the globe at high altitudes, and it plays a crucial role in shaping our weather. It acts as a boundary between cold polar air and warmer air from the lower latitudes, guiding weather systems from west to east. The jet stream, a band of strong winds high in the atmosphere, is driven by the temperature difference between the cold Arctic and warmer lower latitudes. This temperature gradient is what gives the jet stream its strength and stability. However, as the Arctic warms, this temperature difference decreases, causing the jet stream to weaken and become more erratic. As the Arctic warms, this temperature difference decreases, causing the jet stream to weaken and meander. A weaker jet stream can lead to more extreme weather patterns, as it allows cold air to spill southward and warm air to move northward more easily. This can result in unusual weather events, such as unexpected cold snaps in typically mild regions and unseasonably warm temperatures in colder areas. This can lead to more extreme weather events, such as prolonged heat waves, persistent droughts, and heavier precipitation events. Heat waves can become more intense and last longer, putting a strain on energy resources and posing health risks to vulnerable populations. Droughts can devastate agricultural regions, leading to crop failures and food shortages. The weakening jet stream can also cause weather systems to stall, leading to prolonged periods of extreme weather. When weather systems stall, they can bring extended periods of rain or dry conditions, exacerbating the impacts of floods and droughts. This stalling effect can create a feedback loop where extreme weather becomes more frequent and severe. For example, a stalled high-pressure system can block rainfall, leading to droughts, while a stalled low-pressure system can bring days of heavy rain and flooding. These prolonged weather events can have devastating effects on communities, causing water shortages, damaging infrastructure, and displacing populations. The consequences of these extreme weather events are far-reaching, impacting agriculture, water resources, human health, and infrastructure. Farmers may struggle to grow crops in changing conditions, leading to economic losses and food insecurity. Water resources can become scarce or contaminated, affecting both drinking water supplies and ecosystems. The melting North Pole is also linked to changes in ocean currents, which play a vital role in distributing heat around the planet. Ocean currents act like conveyor belts, moving warm water from the equator toward the poles and bringing cold water back toward the equator. This circulation helps to regulate global temperatures and weather patterns. As the Arctic warms and ice melts, it alters the salinity and temperature of ocean water, impacting the circulation patterns of these currents. Fresh water from melting ice dilutes the salty ocean water, which can disrupt the density-driven currents. Changes in temperature can also affect the strength and direction of these currents, leading to shifts in climate patterns. These changes can have cascading effects on marine ecosystems, fisheries, and global weather patterns, leading to further unpredictability and potential disruptions. Marine species that rely on specific temperature and salinity conditions may struggle to survive, affecting biodiversity and the livelihoods of communities that depend on fishing. The interconnected nature of our planet means that changes in one region can have far-reaching impacts, highlighting the importance of understanding and addressing the consequences of a warming Arctic.